for coming. My name is Alyssa Lanja. If you guys are from 4Geeks already, you probably know who I am. If you're not from 4Geeks, then welcome to our events, to our community. 4Geeks is a coding bootcamp. We're located in Brickell in Miami, and we offer programs in full stack development and artificial intelligence machine learning. All of our programs are online and part-time, so it's very easy to take them if you have a full-time job. You don't have to be right in Miami. You can really be anywhere in the country as long as you have a laptop and you're available during the time that the class is offered. So 4Geeks partners with a variety of different organizations and individuals to host different events and to introduce you to new coding skills, new soft skills, new career opportunities. Our events are always different, but today's event, we have Claudio Desalvo here. He's going to be going over software architecture. So I'll pass it over to him and he can get started.
Okay, perfect. Thank you. Well, I think we are all ready. So let's start. So the idea for today is have an introduction about what is software architecture. Maybe some of the attendants or participants of this workshop already are working as a software developer or another position, data developer or web designer, front-end, back-end, different position in the development ecosystems. And the idea is introduce the concepts of software architecture. It's a beginning, it's introduction. We are going to see many concepts and definition in a high level. Then in a homework, you can research a little more about that. And also I'm available at any time from different places. You can contact me, make questions after the workshop. And the idea is after this workshop, you start doing some questions about software architecture. And if you like it, get more into this discipline, engineer discipline, and start becoming a software architect if you are not yet. I don't know if somebody's already working as a software architect or something architect, because today we have software architect, data architect, cloud architect, solution architect, wow, many architects, right? So we are going to talk about software architecture, not the position, the discipline. Okay. Any question in the middle, just, or we can write in the chat, or in the middle, I'm going to open a question and answer in different moments where we can back and forth different questions, or if you have any doubt or want to say something about some of the definitions that is not clear, or want to clarify something, just raise the hand or put a note in the chat, and we can talk at the end of the workshop, where we are going to have 20 minutes, around 20 minutes, to have a question and answer section. Okay, let's start. So, like I said, let me introduce to myself first. My name is Claudio Desalvo. I've been working on IT engineering, software engineering market since 25 years ago. I started as a software developer. I'm a software engineer from a public university from Argentina, where I came from. I work in different industry. I started working in bank industry, creating old-fashioned system like client servers. Then we are going to see what is a client server. Creating software with Visual Basic 5. I don't know if somebody knows what it is. Maybe yes, maybe not. But I'm talking about 25 years ago, right? And then one day, I started getting worried about the quality of what I was doing, right? And the quality led me to, okay, what is software architecture? I start investigating. And finally, one of day, with 3 of my friends, decided to create a company of software architecture, and then continue my career as a different position in the IT market. Project manager, business developer, leader, but always be a developer and an architect in every project. I like what I do, and also I like to be in contact to the source code as close as possible. What is the objective of this workshop? Like I said recently, I want you to start make yourself questions about the quality, make yourself question about what is software architecture. I'm applying some techniques. The software that I'm doing is taking into account quality attributes. All of these terms we are going to develop more deeply in the other slides. So as a software architect, with my experience and trying to evangelize this in every workshop, company, any times that I have the opportunity, try to evangelize these concepts. We are going to see some techniques to evaluate architecture, some techniques to document architectures. We are going to talk about different software architecture views. We are going to talk about different concepts and terms in high-level definition. And then some of them we are going to develop a little more, and other ones we can discuss at the end, but could be in the next workshop. Okay, this is the agenda for today. First, we are going to start to try to define what is software architecture. We are going to see different definitions. We are going to see why it's important, right? Here we are going to stop a little bit. We are going to discuss, we are going to see definition, components, and many other elements or artifacts around the software architecture. Then we are going to talk about pattern and designs, pattern reference models, software pattern architectures, then quality attributes. And finally, this is just small topics about documenting software architectures and evaluating software architecture. Why I say small? Because those two topics are two books. Every one of these is a book. Documenting software architecture, we have many books. Evaluating another ones, we cannot cover all the definition, and I don't want to get lazy with a lot of terms. Just, you need to know that we have something to document, and you need to know that we can evaluate software architecture. Okay, just a deal breaker, something that maybe you are, something happening in your development, right? So what happened? Something failed. Okay. Then we're going to see what fails here. Nice feature, right? Who wants this feature in the software? Okay, it's a feature. Maybe you implement it, but nobody wanted it. Okay, a workaround. Always we have a workaround in our architecture, in our design, because we did something and now we need to fix it. Normally, this is a situation when we are fixing bugs in production, really complicated. And we don't want to finalize our developer days like this, right? Just a shows between situations, but this happened, right? This happened. I'm completely sure that I don't know what is your experience in the market, but I'm completely sure that somebody deal with some of these situations for different reasons. But maybe now we are going to see or to discuss. But something important that I want to share with everybody and try to be, if you agree about it, right? Having a reasonable software architecture is important to the successful development of the software. I think I would like that everybody's agree of that, right? Put a sticky note over there and think about it. Okay. Let's review a typical software architecture. Typical. That doesn't mean that this is a real architecture, but normally what we have here, right? If we try to discuss what we have here, we have a layered architecture, maybe divided in tiers. You know that layer and tier should not be similar concept, but different. From the implementation perspective, should be different. We have internet, good. So we have a connection to the world. Firewall, okay, something tell us we have security. Somebody wants to take care about security. We have a database. In that case, it's an Oracle. And then we have two layers that pretends to implement some abstractions from the database. That's what I'm trying to understand of this diagram, without to know business requirements, functional requirements, business goal, objectives, nothing about the software, just reading this documentation, this diagram. Right? We have workstation, connectivity, access control. Maybe it's telling me that using a password or some authentication and authorization mechanisms. Login services, somebody wants to log transaction to maybe monitor, review later. Okay. This is one architecture. This is another typical high-level architecture. This is real. This is something that I did in one of the latest projects that I've been involved, right? High-level architecture, just squares, arrows, telling me something that about relation between elements and components. We are creating a definition, right? Elements, components, actors, artifacts. And the same architecture is here a little more complicated. This becomes more complex. Looks like it's a pipeline and filter with queues, with more components, with more artifacts, with a lot of more relations. But I still don't know many others definition about if it's a good architecture, it's not a good architecture, just it's architecture, right? Okay. So before to start talking about the definition about what is software architecture, because there are many. If you search in the web, what is software architecture, you can find a lot. I'm going to grab just one because I like it, and it's because I'm more aligned to this one than the other one. Doesn't mean that it's not correct, right? It's just because I like more than that. But before to that, I would like to introduce two disciplines around the software architecture, right? So we have enterprise architecture. We have system architecture, right? So what is me? Well, what is a software? Sorry, what is enterprise architecture? Maybe the word is telling you something. Enterprise architecture is more a description of the structure and behavior of an organization process. Information flows, organization, subunits. However, an enterprise architecture needs to be included in a computation information system. Just by itself, the enterprise architecture doesn't exist too much, right? It's more high level. We are not talking about implementation. We are not talking about some techniques or software or database particularly, right? And then we have the another one is a system architecture. In a system architecture, what is? System architecture is a representation of a system where we map the functionality in the hardware and software components, right? Well, going a little deep level, right? And finally, we are going to try to define what is software architecture. This definition is based on the software engineer series from Carnegie Mellon Institute. I don't know if somebody read the books, but Software Architecture in Practice. This is the book. The majority of the concepts come from there because I'm aligned to this institute and the concept. And what is this? Let's read one by one, right? The software architecture is a system. Recently, we were talking a system. System is a set of structure needed to reason about the system. This structure compromises, sorry, no, this is not the definition. Yeah, yes. This structure comprises software elements, relation among them, and property of both. Right? We have elements, relations, relation among them, and properties. If you go back to any of these architectures I show you, we have elements, relations. The properties are not described here, but here also we have elements, actors, database, relation. So these are bidirectional relation, bidirectional. Here, more elements, a lot of more relations. So basically, this is from high level, the definition of software architecture. Like I say, if you start searching in the web, you will find a lot of more. I invite you to research it, search it, compare, find the try to find the difference between one. In this one, we are making more focus on elements, relation, and properties. We're gonna see that why, and compare the different concepts. Okay. One thing that I would like to make sure with everybody, right? Architecture is an abstraction. Why is an abstraction? Okay, because it consists of elements and relation, right? So it's not something that is concrete, right? We are not going to define perfectly and deeply detailed in an architecture. It's impossible, because you never can define fully attributes, all the elements, all the relation, because not all information is required to define an architecture, right? Every software system has a software architecture. This is clear. Since a monolithic, simple Excel file, this has an architecture. This is the architecture. Till the cloud, microservices, distributed computing. This is also another architecture, right? But every software system has a software architecture. This is clear. Maybe you don't see it. You it's not documented. It's not defined. But there is an architecture. And not all architectures are good architectures, right? But what defines that? Who make this decision? Okay. And we're gonna see what is the purpose, why is important software architecture. And we can do, like I said, like I showed you recently, right? In this, remember this feature? Maybe this feature is correct, is the most difficult feature that you made in your software, but it's not important. Who won it? It's not necessary for the architecture, but you introduce it. Why? Okay, we need to see why. Maybe there were some stakeholders that request that. There was a business functionality that requested that. There was a quality attribute that requests that. We don't know. We need to know, we need to understand that, right? Okay. Recently in the definition, we say that the software architecture of a system is the set of structures needs to reason about the system. Okay, set of structures. Oh, perfect. Here we have again the same, right? Architecture is a set of software structure. And these software structures, how are defined or divided? Initially, we can divide it in 3 types. The idea is to see a high-level definition of this, but there's a lot of more about each of these structures, right? Component and connector structures, module structures, and allocation structure. Okay, component and connector. What is this? This is mostly associated to runtime components, unit of computation, and the connector between them, and the communication between them, right? The modules. Okay, module architectural elements that are unit of implementation, call it modules. Normally, we can say that it could be a module, another module, and the relation between them, right? And allocation structure, software elements and their relationship to external environment, which the software is created and executed. This is more implementation, right? Think about it. Let's switch to another industry, like medicine, and the different ways to view the human body, right? It's not the same view for a cardiologist or clinical or another doctor that want to see different aspects of the human body, right? The idea of this architect, this structure is to show this different view to the different stakeholders that want to see different attributes, elements, and the relation between the elements in every occasion, right? Okay, so any question until now? Somebody wants to ask a question, anything that I want to review? I will give you 1 minute, 30 seconds. Something want to write something before to start with a pattern and reference. Okay. Okay. Well. Okay. So just to review, remember this concept is very important, but try to understand that the architecture is an abstraction. So as much as information we have in architecture, for example, in this architecture, we don't have any legends, we don't have, it's an abstraction of this design, right? But this architecture is not telling us what is the runtime, how the layers are separated, they are together, they're not together. In terms of process, programming, or hardware, there's nothing associated. Object, task, function, processes. What is the responsibility for every element? We don't know. Why these are dotted lines? It's a little more thin lines, and this one is no. The difference between this line and this line. Why? Which data is sent between the layers? We don't know. Which user is using just basically we have a customer that looks like calling the customer services. The customer service looks like it's using a workstation and go directly to the app, but also the user can use the application through the internet. I'm not telling too much information. I don't have any reference how to interpret this. It's just it's an abstraction, right? This is similar, right? From more high level. This is the same system that this one, sorry. This system, the workspace management finally become in this workspace management. So here again, maybe the language, the semantic of the artifacts like this one make me understand that this is a queue, something where I persist information. Okay, but what information? It's not documented. I don't know if I'm persisting a flat file, I'm persisting a binary file, I don't know which protocol I'm using, assuming that if this is a queue, because it has the stereotype of a queue, and also say analyzer queue, orchestrator queue, clean queue. Well, I'm assuming that the system is using a queue manager and the protocol maybe Java Message System, JMS, or another IBM message queue, I don't know. Then here I have a service that provides an abstraction of the database, that is a SQL, but I don't know what I'm storing. A library that maybe has common functionalities, I don't know. And a scheduler, okay, looks like this is a process that's running under a period of time. I don't know how many times, once a day. Again, it's an abstraction, but maybe depending on the context and where we are, need more information to communicate, right? To become something important from the architecture, right? Okay. So patterns, reference model, and reference architectures. I'm completely sure that you heard about patterns, design patterns, right? Gartner 4, this is the big ones for guys that start creating the enterprise design patterns. The majority of us here, I'm completely sure they use MVC, model view controller, client server, microservices, command, pipe and filter. Wow, we have a lot of patterns and designs. The idea of the pattern is fix a common problem with a common solution that can be replicated, right? Basically, an architectural pattern is a description of elements and relationship type as a constraint. This is the constraint and how they are used, right? Model view controller, you know how to use it. You have to have a decouple between the model. We have a view and we have a controller that we use the model to post in the view. Command, exactly the same. We have a functionality and a problem and a pattern command fix. Client server, most used pattern, the website, the website, the web is a client server, right? Today. Microservices, and many others. Well, a reference architecture is a reference model that is mapped onto the software element that implement the functionality defined in the model. Right? We can find many different reference architecture in the market. Also, there is a domain architecture for the different industries that we can use it and implement it. And a reference model is a division of the functionality into elements and data flow between them, right? For example, a reference model includes database and compiler, among other things, right? For example, a reference model, we have parsers, analyzer, code generator, optimizers, I don't know, data flow, connectivity between the pieces, right? Then in the reference architecture, we have pattern and define the family of architectures such as client servers, say pipe and filter, then different architecture model, right? The mapping does not have to be one-to-one. Software might implement one function, part of a single function, or many functions. That allows us to create a template that define standards and tools to speed up developments. It helps to implement or adhere to a constraint prescribed by reference architecture, right? For example, if somebody is working on Java and we want to use the Spring, basically Spring framework using a pattern, right? The inversion of control pattern. The main objective, inject the references without to have to be worried about the implementation. High level. I'm not trying to define deeply what is mean inversion of control, but this framework is an architecture reference with a reference model that help us to deal with this situation. when we want to decouple the implementation from the interface, right? Everybody knows, okay, I want to do that. I want to use inversion of control. Okay, with framework in Java, Spring, .NET, we have a Spring.NET, we have other one, I don't remember. I'm not expert on the other languages like Python, but I'm assuming that the other languages also have this kind of pattern, like MVC. For MVC, we have many frameworks, Strat, Spring, MVC. In .NET, we have ASP.NET implementing model view controller, the model view presenter. So we have different model, different architecture reference that implement the patterns. Okay, I'm assuming that if you can write which pattern that you're using normally, write it. So now, let's think about why software architecture is important. Okay. Well, before to that, see anybody wants to give your opinion why a software architecture is important? Give you 30 seconds. Think about it. Why you think a software architect is, or maybe you think, no, it's not important. It's okay. We can discuss it. But let me know if somebody wants to. I don't see the chat. Let me see if I can see the chat. If somebody wants to write any thought about why it's important, it's the moment. I give you 30 seconds to think about it. Okay. Well, let's think about these three primary reasons. There are many, but I think this one of the three most important why software architecture is important. First, it provides a vehicle for communication among stakeholders. What is a stakeholder, right? This is a word that everybody heard in many meetings or documentation or mail. So a stakeholder is somebody that is involved in the system definition, right? It could be a user, project managers, developers, DevOps guys, admin guys, customer, clients. Everybody that can influence how we are going to create our system is a stakeholder. And those are stakeholders, obviously, because they have an influence in our system, it's important to have a good communication with them, right? How we can communicate within them with a good software architecture. Try to explain, try to document, and try to use the software architecture as a vehicle of communication, right? If we need to understand why a client wants a transaction execute in less than 1 nanosecond, wow, less than nanosecond, what are you doing? So are you buying them in the stock market, something? The system is a real-time stock market? Okay, maybe yes. Okay, if the system is just I don't know, e-commerce, maybe nanosecond is not necessary, maybe milliseconds, 1 second, or the system needs to support 10 million of users concurrently. Wow, okay, 10 million of users? Oh, we can show the architecture that we need to develop to support 10 million of concurrence architecture to communicate what we are doing to this stakeholder. Well, what I was saying, performance, availability, maintainability, think about about those attributes, right? Second point, say, if the manifestation of the most important design decision about the system. Remember that. A software architecture, once is defined, the idea is not change it constantly. Because if we are constantly changing our software architecture, we don't know, we are not clear what we're going to do, right? So imagine that if an engineer industry, every 2 weeks, we are changing the scripts or we are changing the architecture of the building. Now we are going to do a house, no, a building, no, a single family, no, a multifamily. No. Okay, what do you want? So let's define what we want, document it, put in a solid architecture reference with a model, and use this to continue working, right? If our architecture were thinking about monolithic software that's like a black box that enter a message, process the message, output. It's okay. Works? Yes, works. But maybe not scale. In the future, it's complicated to introduce change the functionality. The performance could be different. If we want to scale, it's going to be more complicated. But the architecture at the very beginning does not have into account these features of these quality attributes, right? Because the decision that we made in the past now cannot. If we are going to change the architecture, the trade-off is going to be high, right? It's going to be expensive. What to want to avoid is those big changes, right? And number 3 is reusable. A reusable abstraction of the system. So like we said, we can reuse, right? So the architecture defines constraints in implementation. So when we say communicate among stakeholders, we can negotiate requirements with the users, right? We can keep the customer informed of the progress and costs. We can implement management decisions with a communicating architecture. This communication allows us to predict system quality attributes without waiting until the end of the road or the system is developed. And we realize that, oh, we do not have into account, or we did not have into account the availability. This is a system that needs to be 24/7 up and running. It's a airline control system. So full tolerance. So, oh, but I already did. I do not have implement any techniques that support full tolerance feature. Okay, that's decisions was not made. And that's why it's important documented in the software architecture. And it was important to have this defined in our software architecture. Okay, and when we say reusable abstractions, so we define a model that we can transfer across similar system. The software architecture can serve as a basic of a strategy to reuse agenda that reuse requirements, developments, code, experience, standards. So architecture supports building system using large, independently developed components, and also architectures enable template-based. We can templatize our implementation. It's more easy. The idea is to learn, right? Okay. Well, what we saw here about patterns is a high level, right? So every patterns that could be implemented in a software architecture definition is a huge information. We need to investigate why, we need to deal with the functional requirements, goals, what is the goal of the system, and why we are implemented, communicate, document the decision, and finally define this abstraction model, right? What we saw here is high level, remember. If you want to investigate a little more, just you can start researching about enterprise architecture pattern, design patterns. There are many of them. And the idea is that you start to thinking about this pattern when you define software architecture and not start thinking, okay, what I'm going to do. Okay, imagine that I'll tell you, I need a system that do a process, and in every step that I do something, I need to incorporate something else in the next step. And another step, process, and incorporate something more. Finally, produce an output, right? Well, mostly it's a pipeline, right? In every pipe, I'm doing something that produces an output. That is, output is an input from the next iteration in the filter, and produce another. So basically what you can start doing is, okay, I'm going to grab the reference model or the reference architecture pipe and filter, implement it. You can grab the implementation from many different books or solutions or frameworks that already do that and use it. But if you don't know or you don't have the concept of patterns when you think about your software architecture, you are going to start to reinvent the wheel every time that you create a new system. Or when you try to understand what a system is doing. That's the purpose for the pattern or design pattern. Then nobody knows by memory all the patterns, but you need to know that there is 95%, there is a pattern that fits or that is suitable for what are you looking for to implement. If not, think about it. Maybe you can split your solution, and when you split your solution and divide it into 2-3 pieces, every piece implement a different pattern, and then communicate each other with another pattern. Mostly it's in that way. At least you are doing something completely new. I'm not imagining right now what could be. Okay. Mostly, a system is defined by the functional requirements. So what we do as software, what we do as a system, because we have a requirement by a stakeholder, could be the user, could be a customer, internal customer, a client. These requirements need to be implemented in a system in order to produce a result or an outcome. Okay, but the functional requirements does not define the architecture. It's a definition, right? Remember that. The software architecture is aligned to the goals, to the requirement, to the missions, to the objectives, but the functional requirements does not define the architecture. What does it mean? If I have a functional requirement that's telling me that when I click in the button, show up a pop-up, okay, I can implement. But this functional requirement is not telling me nothing about quality attributes. How fast you need to render this pop-up is not in the functional requirement. How readable, what is the usability about the pop-up? What happens when the pop-up fails? Nothing of this information comes from the functional requirement. And this is something that I can reduce in quality. It's not a negotiation, but when we are in the middle of sprints, planning, in a meeting with stakeholders, with the project manager, with the Scrum Master, our commitment with the quality should be as much as possible, right? I'm going to tell you an example of what happened recently to me, right? I was doing a software architecture assessment for an API, and I realized the APIs does not have any security. No, you can consume the API, just grab Postman, do the post, do the get, send the correct information in the correct format, and the API responds. Wow, so I can hack this, or I can do whatever with this information. There is not any simple API key, client ID, client secret. There's not authentication and authorization mechanism introduced. No. Why? No, because this is going to take a lot of time to the legacy system to implement security. What? I don't care. So we cannot negotiate, do not have security because somebody doesn't know how to implement it. Okay, let's do what we have to do to implement this quality attribute, which is security, which is today in an API that is exposed to internet is one of the most important quality attributes, security. We are not implemented because somebody doesn't have to implement security in a legacy system. Okay, we cannot negotiate, right? So that's quality is never an accident, right? It's always a result of high intention. It's in purpose. Quality is in purpose. You are implementing quality in purpose. Sincere effort, intelligent direction, and skillful execution. That's why we cannot negotiate quality. Obviously, there is a trade-off in this negotiation, right? When we talk about security, maybe implement security, not 25 mechanisms of security to become really complex to consume the API that simply return me a zip code list. Okay, but at least basic security, right? But obviously introduce a more complex security techniques when we are going to do a payment transaction. Bank payment, a transfer, or we are going to buy a stock option or monetary or financial, depend on the requirements and the goals, but the negotiation should be managed. Like I said recently, functionality does not determine the architecture, right? Perfect. Well, I'm going to list a couple of most common quality attributes. I think they are the most common. High performance, security, reliability, usability, reusability, availability, configurability. All availability mostly are quality attributes. And if you want to start thinking about where do I start when I have to define an architecture? Okay, start from here. Imagine that somebody requests to you, okay, I need to create a new system. I need to do an airline system, right? Or I need to do a system to book a seat in a train, right? Okay. So basically, we have the train, seats, the people log into the system, buy Check. Okay. You need to design the solution. Start thinking about the quality attributes. Think the definition of the software based on the quality attribute. This is called quality attribute driver. It's going to be easy because, okay, we need performance, we need security, and you're going to start thinking which other components need to have into account in the architecture. And when we complete, your architecture will be more robust, right? For example, we have a requirement that say, I need to increase the market share. Okay, my application, my system need to have more focus on usability and modifiability attributes than other ones. Doesn't mean the other one doesn't have to take it into account, but it's more, those are most important. Maintain a quality reputation. Okay, performance, usability, availability. I need to have the opportunity to introduce new capabilities simply. Okay, performance, availability, modifiability. Provide a programmer-friendly framework. I need to have the ability to modify constantly. And integrate with other systems, portable, interoperability, modifiability. That's how you have to think your architecture based on the requirements, goals, business goals, right? Okay, so this is high level. So every topics, I recommend that you research to understand more, but you have to know that we have three contexts or three moments when we define or when we try to understand the quality attributes, right? The first is specifying a quality attribute, right? That is a quality attribute scenarios, right? Environment, there is a source, there's a stimulus, there is environment, there's an artifact, there's a response. All of these concepts define a quality attribute. Then, how we achieve these quality attributes, right? And like I said before, mostly of the design architectural patterns or techniques, tactics, are 100% associated to quality attributes. If I want to have maintainability or the ability to change quickly, or to redeploy without to have to compile all the application, I will use some inversion of control. Or if I'm going to change a lot of views without to change my reference model, okay, MVC. Or if I'm going to have a proxy or a place when I'm going to receive a transaction and base it on a rule, I'm going to throw this information to another system to process. Could be a proxy, could be a command pattern, because we need interoperability or another quality attribute to be implemented, to be achieved, right? And finally, we need to understand if we analyze, we need to achieve, okay. We need to analyze if these quality attributes are okay, right? So how we measure, right? If we are good, our performance is good, our availability is good. Okay, there's different tactics in the design that based on questionnaires or other techniques that are used to define if the quality attribute was achieved, or is correct, or is not correct. Example, we can do some monitoring in our system to understand if it's 24/7, how many downtimes we have the system. If the downtime is 0, our quality of reliability is good. if our constraint about performance is 1 millisecond per transaction, we can do some logs or monitoring to determine if every transaction that we are executing is in the measure that we need. We need to measure. Otherwise, we cannot understand if the quality attribute is correct or not, or if we are aligned to the goals. Okay. So now we are going to talk about two important techniques. We say that is document software architecture and evaluate software architecture. Why is important? Well, document is always important, right? I'm completely sure that if you are working in maintenance software, for maintaining software, I'm sure that you have many moments where the no documentation, no information, or many things that don't help you to do your work, right? So where is documentation? This API, where is the documentation? How can I use this API? Or we have a bug, we need to fix a bug. What is the documentation of the system? How they communicate each other? What is the architecture of the system? Okay, so we don't have it. So that's the reason why it's important to document the architecture. Basically, I define 4 important moments, but it defines the work assignments, quality attributes. We can understand the quality attributes, early access or early analysis, and also we can do a post-deployment maintenance. So once we need to maintain a system, we need to have the documentation. The architecture needs to be documented, right? And what is architecture documented when? What is used for construction? Oh. Okay. Okay. Sorry. Me falta un cosito. Bueno, me lo sacaré. Okay. There's an error here. We have a bug. Okay, the idea is the architecture is used when construction to tell the developer something, what we build, how is the pieces talking each other. So analysis, so document the architecture, the jobs, risk analysis, problems that are uncovered, design, education. Okay, someone that is new in the project, how we educate these people, or these new developers to the system, and also communicate. Without documentation of the architecture, we cannot communicate our system. Okay, and by the end, a software architecture must be documented and can be and should be evaluated, right? Why we need to evaluate a software architecture? Because we can determine the structure of the project, analyze why in this moment, evaluate. Imagine that we are buying a new system. We need to evaluate the architecture of the system that we're buying. When we need to analyze the quality attributes to compare the architecture, what is the benefit? Obviously, with a software architecture evaluation, we are going to have enough information to understand how is the health, how is the maturity model of this architecture, which are the problems that we can have using this architecture, communicate with the stakeholders some situation of this architecture evaluation. And finally, I put the cost because it's a cost, right? So we need to involve some senior guys from our company that need to be involved in this software architecture evaluation. Normally, a software architecture evaluation happens when you have an issue that is from high level. Example, my system is slow, okay, or the functionality that I think it was working now is not working anymore. We need, and the systems are complex. They have too many components, relationships, and many systems that need to be evaluated to understand what is the issue from the architecture. Could be bad decision at the very beginning, performance issues. Mostly when you evaluate an architecture and associate it to quality attributes. I can say that 95% of times for architecture evaluation is associated to quality attributes. So we say, okay, in performance, it's not reusable, it's not reliable. Normally, this is the conclusion of an evaluation of software architecture. And also we have techniques. So this is not something that we can do. Yeah, you can do it like suggested, but there's techniques that when you have questionnaire techniques, and also we have measure techniques. There's a technique called ATAM that you can research about that. That also is recommended by the Software Engineering Institute. It's a way to evaluate a software architecture. Well, that was everything. That's all. So thank you for being until the end. So if you have any question, please write it. And this is the moment that we can share some question, anything that you want to clarify, just let me know. And we can have a couple of minutes for that. And then we can finalize the workshop. Any opinion? Something new concepts are not getting involved too much in this. It's too much, too new. There's too much high level. Any feedback? Good to know. Again, thank you very much for your time. We have 1 more minute, and then we are on time for the workshop. Okay, I'm assuming that maybe they are a little shy to answer to some questions. So you can contact me from LinkedIn, or I also in the Slack for the 4 Geeks available. So perfect. What your message? Okay. Thank you. I think. Perfect. Thank you, Benigno. Okay, I hope this information helped you. Like I say, it's a high level. Every day we need to review this concept. Every day we need to try to implement these concepts. I know it's not easy because sometimes we are only developers. The decision, we cannot make all the decisions. But try to get involved at least, or why you're doing this, or proposing. If you're always using industry patterns or models or domain models, you will be in the right path. Try to understand why somebody is asking you to implement an API without security. Because as a developer, sometimes we receive the requirements and we say, okay, I implemented, I did it, I did my work. But well, as an evangelist, we try to say, okay, why you wanted this? Or why you're trying to use a JSON database when we are managing relational data information. a non-SQL database just because it's fashion, because everybody's using Cassandra or everyone is Mongo, I have to use it? No. Depend on the structure, depend on the model, depend on the business requirement, and depend on the quality attributes of the software architecture that we need to implement. Okay, guys. Well, thank you very much for your time. I would say that we call it a day. Hopefully see you soon with a new workshop with the next concepts. Okay, thank you very much. See you.